any number to the power of 5, for example, is repeated multiplication. So we have 5a's. The point of this video is to show that logarithm is the opposite repeated division. So if power is repeated multiplication, the logarithm is repeated division. So let's say you are given this equation. 3 to the power of x is 81. So how much is x? Let's divide 81 by 3 and we get 27. Let's divide 27 by 3 and we get 9. Let's divide 9 by 3, we get 3. And let's divide 3 by 3, we get 1. So we used the number 3 4 times, so the x equals to 4. Now, this equation 3 to the x equals 81 is totally equivalent to x equals log of base 3 of 81. So logarithm is just repeated division. We divided 4 times and x equals to 4. Getting the decimals is a little bit trickier. So we calculated log of 81 with respect to base 3 is 4. Now let's calculate the log of 150 with base 3. So log of 150 with base 3 is 4.56. How do we do that manually without this formula? So let's input 150 and divide it by 3. We have to divide 1, 2, 3, 4 times. That's this 4 over here. So we divided until the result was less than 3, less than the base. Now, because we are in that decimal number system, that means we have to raise this result to the power of 10. And now we repeat the same process. We divide by 3 and count how many times we divide. 1, 2, 3, 4, 5. Now our result is less than 3 and we divided 5 times, and this is this first decimal. To get the next decimal, we have to raise our result to the power of 10 once again. And now we divide by 3 to get the next digit. We divide 1, 2, 3, 4, 5, 6 times, and now our result is less than our base 3, and we get our second decimal 6. You see, in binary this would be simpler, because instead of raising to the power of 10, we have to raise to the power of 2, or just to do the square. Okay, so we are going to open the Visual Studio. So this is Visual Studio Community 2015. We are going to create a new project. File, New Project. We are going to choose Visual C++, then Win32, then Win32 console application. Let me name it Calculating Log. So we click OK. Next, uncheck all of these, check empty project, console application, that's okay. Now finish. Okay, so we created a project. Now we have to create the file, the C++ file. Source files, add, new item, C++ file, source IP, that's okay, add. So we will use standard input-output library. Now let me type in the main function. So let's define two real numbers. Real number A and real number B for base. Let's set A to be something big like this, and the base, let's set it to be 7 point something. Okay, so we all know how we calculate logarithms. Oh yeah, we're going to have to include math.h. So we can use the logarithm function. So to calculate logarithm A with the base B, we'll need to define the result first. And the result R is equal to log A over log B. And now we will print our result just to see what it is. So let's run this and let's see what log A of B is. Debug, start without debugging. So it's 9.553 whatever. Let's copy that. So logarithm of A with respect to base B is R, and it equals to 9.55, etc. So we calculated this logarithm by using the log function, which comes in math standard library that comes with the language C++. But what if we didn't have the log function? How would we calculate the log of A with respect to B? if we didn't have the log function. Let's do that now. Let's try and figure it out. So as I said, logarithm is repeated division. So we have to divide. Number a with the number b, and until number a is less than b, and that will be the integer part of our result. So let's try and write a code that does that. So we declared the variable a and assigned the value a to it. We declared the variable ri, which will be the integer part of our result, and we initialize that to 0. The right way to initialize it is like this. And we do, while a is larger than our base, our b, we divide a by b and assign the result back to AA. Also, we keep track of how many times we did the division, because that will be the integer part of our result. So now let's check if I is 9, as it's supposed to be. So we go to debug, start without debugging, and as you can see, the value is 9 and the correct value is 9.55, etc. So this was the easy part. Now a little bit harder is to find the decimals. Okay, so let's do that now. Okay, so what are we doing here? We define this P. I call it P for position because in binary system, when we divide this P by 2, this will change the position of this 1 and move it one position to the right. Every time we divide by 2, this P will be 1 shifted to the right by 1 place. Now we have this loop 4, and it's going up to 60. Before there are 60 places. Actually there are 54 places in the double for the significant bits, but let's go to 60 anyway. And now we are squaring the A. So AA times AA times AA, and we save it back to AA. So we square it because binary system base of the binary system is 2. So we need to get the AA to the second power, and that is just a square. So we square the AA. We position the P, and then we check if if squared AA is bigger than our base B, and if it is, we add this bit to our result. Now this should be it if I didn't make a mistake. So let's run this code and see if Ri is equal to Rr. If Ri is equal to R. So we go to debug, start without debugging. I have made a mistake, so let's check this. Yes, this is where I made a mistake. We also need AA over B equals B. So let's try this again. And yes, look, these two numbers are the same. So we have just made an algorithm that calculates the log function if in any case you didn't have the log function available to you. You can calculate the logarithm in this way. For example, if you have a microcontroller and for some reason you need the logarithm calculated on the microcontroller, you can do it like this. If you like my video, like, subscribe, and thank you for watching.